cones right here. And if you have a plane that goes diagonally down through the cone, it forms this section, this conic section, known as an ellipse. All right? And what we're going to be doing in this video is going over the different parts of an ellipse. So we're going to go back here. Right now, this 2, 3 is the center of our ellipse. That's our HK value. So you should have that right there on your paper. What we're going to do first is we're going to go ahead and draw the ellipse. I have a little bit easier tool to be able to do this. You probably don't have this tool. I'm going to make it to the best of my ability there. There we go. So there's my ellipse. If you're doing this by hand, I would start at the -1, 3, and I would just arc going up until you hit the 2, 8. Then section it out. Do that section. Then this section, and finally the last section. So it kind of gives you, you're able to draw it section by section, makes it a little bit easier. So go ahead and do that right now. Draw your ellipse as best you can. Make sure it goes through -1, 3, 2, 8, 5, 3, and 2, -2. The first thing that I would like you to do after you draw this, okay, is I want you to draw a nice long segment right there going all the way through the center of the circle. And I want you guys to label this long segment as the major axis. This long segment that goes through the center of the ellipse is a major axis. So I want you to write on your paper, the major axis is always equal to 2 times the value of A. And right now, A doesn't make a whole lot of sense because we haven't written the standard equation of an ellipse yet, but eventually it will make sense. By the way, how many units from an 8 all the way down to a -2? How long is that? 10 units, that's right, 10 units. Which means our A value will eventually equal a 5, because 2 times 5 is 10. So right here on your paper, put your A value will equal 5. Next thing I want you to do, I want you to draw another line segment going through the center. Now, in your journal, what I'd like you to do is put a little arrow next to this green segment right here and label that your minor axis. That whole thing right there is your minor axis. And your minor axis is going to be equal to 2 times B. And your minor axis is how many units long? 6. Which means your B value will equal 3. Now this is going to be important when we build our formula. Okay? When we build our formula. So right now, we have all the information we need right now to build a formula for this particular ellipse. But before we do this, I want you to notice a pattern. So I'm going to go back to our notes here on the page. Okay? So I'm going to go back right here. And I want you to look at this ellipse right here versus this ellipse. Which one does ours look like? Does it look like the top one or the bottom one? The bottom one. Which means our major axis, right, is going vertically versus over here, where's your major axis running? Horizontally. If it's leading horizontally, you lead out with x minus h squared. If it's leading, if your major axis is vertical, you lead out with y minus k squared. So we're going to do this formula right here. All right, we're doing that formula. So right now, what I'd like you to do in your journal is write y minus k squared over a squared plus x minus h squared over b squared equals 1. This is the formula right here. This is the equation that you're going to use to build an equation for an ellipse where the major axis is the longest going vertically. All right, so now I'm going to build my answer. Y minus k. What was our k value? 3. So you put y minus 3 squared over, a squared. What was our a value? 5. So what's 5 squared? 25. Good job. See, I gave you a chance to correct it. Everybody in their life has done that. Okay? If they haven't, then they just haven't done any math whatsoever. So yes, 5 squared is 25 plus x minus our h value, which is a 2, squared over b squared. If our b is 3, what's b squared? 9. Now what is, I know I'm kind of running out of room here, so I'll erase this right here. And what is this equal to? This is equal to a 1. This is your equation, everybody, for problem number 1. So on your assignment right now, you can transfer this over. There's your equation for problem number 1. Then we're going to find what's called the foci. All right? Now, I'm going to go over here, and I want you guys to notice something really important right here. Do you guys see where it says foci, h, comma, k plus or minus c? So what I want you to do right here, I want you guys to write this down in your journal. C squared equals a squared minus b squared. And I want you to write foci, h, comma, k plus or minus c. Make sure you put that in your journal right now. Please keep all interpretations of foreign languages to yourself in this class. Thank you. People might get the impression that we're in East Texas, okay? Now, what we're going to do next, all right, is we're going to write c squared equals a squared minus b squared. Now, that might be a little confusing to people because we're used to seeing what? A squared plus b squared equals c squared from your geometry and the Pythagorean theorem. This is the formula to help you find your foci. All right, so let's figure out what c is equal to. C squared is equal to a squared, and what was our a squared equal to? 25. There's our a squared. Minus, what was our b squared equal to? 9. 25 minus 9 is 16. Therefore, our c value is going to be a 4. So our c value is a 4. All right? So this formula right here, c squared equals a squared minus b squared, is going to help us find our foci. All right? By the way, foci is the plural of focus. All right? We have 2 foci, which means we don't say 2 focuses. We say 2 foci. This one. Audrey, can you give me the formula for the foci for this? H plus or minus c, comma, k. Now, what? Hold on. I think. Hold on. Let me go back real quick. Nope. It's this one. It's h comma k plus or minus c. I thought something was a little bit. All right. Let me redo it real quick. All right. So we changed it. Here is the foci for this particular problem. What was our h value? Our h value is 2. Our k value is 3, and we have to do what? Plus or minus a 4. So what I want you guys to understand, one of our foci is going to be 2 comma, what is 3 plus 4? It's going to be a 2, 7. Then our other focus, all right, is going to be 2 comma 3 minus 4. -1. So what I want you guys to do right here, these are your foci right here. So we're going to plot these 2 points right here. We're going to plot 2, 7, which is right here. We're going to plot 2, -1, which is right here. Now both of these foci, we're going to explain to you why we need them. Why are they important? Okay? This is your final answer as far as your graph. There's your coordinates for your foci. You're done with that. Now I'm going to go back over to the paper, and I want to make sure you understand why are the foci important. So we have a focus right here. We have a focus right here. Here's the cool thing about an ellipse. If I take a random point, people, a random point, and I connect this point right here, and I make a section from this point on the ellipse to this focus, and from this point to this focus, that distance, right here, the distance, whatever this distance is, plus whatever this distance is right here, will be the exact same distance as if I were to take another point and just randomly put it on the ellipse, and then connect this point to the focus and this point to the focus. Now, if that doesn't make a whole lot of sense right now, that's okay. I'm going to label it. I'm going to call this distance right here A. I'm going to call this distance B. I'm going to call this distance C, and that distance D. What I want you to understand is the distance from A and B together. If you took whatever that length is, A, and added it to whatever length is B, that would actually equal the distance C plus the distance D. That's anywhere. Now, if I slid this point anywhere around and connected it not to the vertice right there, not to that vertex or this vertex, but I connected it to the foci. So, for example, if I said the distance from A was a 4 and B was a 6, and I said C was 2, what would D have to equal? 8. That's the qualities of an ellipse. And that's why the foci are so important. Okay, when we're solving problems, we're going to be solving some word problems with ellipses where we're going to use the formula and we're going to have to find different distances. And what are we going to be using? We're going to be using the foci to help us find distances. So this is your introduction. We'll continue on later on.